So today I think about it, like if I teach you graphing first, that's me giving you an equation and taking things from the equation to build a graph. When I ask you to go the reverse order, it's as if we're working backwards. So we need to find all those building blocks that we use to make the graph. So just real quickly, I'm going to walk around and eavesdrop, have a quick conversation with your group. What are things that you took from the equation to help you build that frame and make that graph? Tell your groups what things you used. Okay, just as I make a round around the room, I hear things like amplitude, periods, starting points. I heard things too like cosine, sine, because you have to know which graph to draw, right? And when you think about amplitudes, periods, and starting points, how did you get those things? Those all go back to your A, B, C's, and D's. So if I give you a picture and I want you to write an equation, you've essentially got to find four things. I guess maybe five if you count like the shape of the graph. But you've got to find four values to plug into that equation, right? You've got to find A, which would deal with the amplitude and whether there was a reflection or not, whether it's going to be positive or negative. You'd have to find B. What can you use to find B? What uses B when we were going back, when we were doing graphs? Period. So if you know your period, you should be able to figure out what that B factor was that you divided by. And then starting point, okay, or think about it more like horizontal and vertical shifts, that's going to help us get our C and our D. Remember that when you're finding C, the starting point or the horizontal shift is really C over B. That horizontal stretch and shrink has been factored in. So when you're finding C, you'll have to already know B. If you haven't found B from the period, then you need to do that first, and then you can solve for C. Okay. And this could be like a sine too, right? Okay. But you're going to have to say, like, you know for sure what each one of those things is and which graph you would use, sine or cosine. So here's an example that we're going to do, and this is the way that I have my examples presented in the notes is a little bit different than the way it's presented on the worksheet assignment tonight. In the worksheet assignment, it actually like gives you the frame, so it has it like I want you to write the equation for this part specifically. So we should all be writing the same equation. But like the truth of the matter is, when I give you a wave like this, depending on translations and things, you could see it as a sine, as a cosine, or as a negative sign, or a negative cosine function. I think it would be good to maybe jot something down in your notes so you have something to go off of. If you want to do it in your notes, a good way to do it just is to draw the general shape of what you're seeing, right? And then label some of those critical points that we would have put on our frames yesterday. So for some of us, the tricky part of this is maybe it doesn't look just like the 8-pane window that we were doing the frame. So we have to put this graph into the context of a frame, and can we find our A, B, C, and D? So I'm going to ask you to look either at the screen or at the one on in your notes. And I want you to look at the image and I want you to see like what really pops out to you in terms of the 4 graphs that are at the bottom of our notes yesterday, the blue sheet. Are you seeing a positive sign, a positive cosine? Are you seeing a reflected sign or a reflected cosine? Anybody want to share like what is standing out to you? UCA. Okay, Aiden says positive cosine, so that's when it goes from max to max. So I'm thinking, Aiden, you're probably right here. And we gotta go all the way to the max. So, you know, like my wave is continuous, but you can create the frame. So like here's the box or the frame for my cosine graph. And then we're gonna do Aiden's, and then I'll see if anybody saw a different graph, and we'll look at that as well. But we're gonna pick this apart, and then we're gonna try to write a y equals a times cosine of bx minus c plus d. And we said it was a positive cosine, so we know that a is now positive, right? Let me ask you this question, because this is really important, especially when you're doing a cosine graph. What is your starting point? Talk to your groups and say what you think your starting point is. What is your C over B comma D? Tell your group, in this picture, what is your starting point? Okay, I'm going to guess there's 2 answers around the room. Okay. 0, 4 and 0, 0. Randall says 0, 0. Why? It's not even on my graph.
Well, because it's the middle between the graphs.
Okay, remember we had this conversation yesterday, and I mentioned it on Friday, although it didn't really mean a whole lot to us. When we talk about starting point, C over B comma D, we're talking about the starting point for the frame. So if it's a cosine graph, be very careful. Okay. The starting point is really 0, 0 here. It does not have to be on the graph. You know, if you look at this cosine graph, it didn't actually go up 4. You know, if you said that the starting point was at 0, 4, you'd be saying D is 4. And because the midline of the graph is the x-axis, it didn't go up. It's symmetric to the x-axis. It has no vertical shift. Okay. So be really careful with that in terms of where your starting point is. And then you can maybe use the starting point to help you with A, your amplitude. What's your amplitude? 4, right? It's from -4 to 4 is 8. Amplitude is half of that, so amplitude is 4. It's a positive cosine. So, you know, like when you say your amplitude is 4, it could be +4 or -4 for A, but because it's positive, we know that A is equal to 4. So we got one of those things figured out. I'm going to skip B for a second, and I'm going to jump down to the starting point, which, remember, and you might want to make a note to yourself, whenever we talk about starting point, we are talking about the frame, not the graph. Okay, so the starting point for the frame was 0, 0, which isn't that supposed to be my, like, C over B comma D? And the only time we ever got 0, 0 as our starting point is when C and D are both zeros, right? So if I can get a starting point for my frame to be at the origin, that's awesome, right? Because then I know C and D are 0. Okay, so C equals 0, D equals 0. Normally, I would say don't solve for C unless you've found B. But in the case that you haven't moved left or right, if your starting point is at the y-axis, then you know C is 0. We got to do B in between here so that we can write the equation. And in order to find B, I think Logan told us we would need to know our period. So what's our period for this graph? 2 pi. Again, if you can get your graph to start at the y-axis when x is 0, isn't this nice? Because from 0 all the way to 2 pi, you know that distance is 2 pi. If you're starting at a different place, you'll maybe have to do, like I did on the board earlier, do the subtraction, okay, so that you can figure out what the distance is. But our period is 2 pi. And what you're thinking about is that comes from 2 pi over b. And we're saying it equaled 2 pi. Well, in this one, it's not so bad. What must be b? Must be 1. 2 pi over 1 is the only way I'm going to get 2 pi. If I divide by anything else, it's something other than 2 pi. On a side note, I'll put it over here on this sideboard, because when your period is something different than 2 pi or something really nice, like oftentimes when it's a fraction, that gets a little bit harder for people to tell, like, what was the factor of b. So if you can't tell what b is, like this one's pretty obvious, if you can't tell what b is, make it a proportion. If it isn't a fraction already, put it over 1 and then cross multiply. So you'd be saying 2 pi equals 2 pi b, divide by 2 pi, b is equal to 1. So if you're ever like, I cannot tell what I divided by, this is weird, it's all fractions, things, there's no 2 pi in there, then you can do a cross multiply to help you out. Okay, so if I put all those things together, then my equation is just y equals 4 cosine x. So, you know, when you compare that to the parent graph that we put in our notes last Friday and we saw again yesterday, the only transformation to that graph is that it's been stretched by 4 vertically. It has the same period as the parent function, so there's no horizontal stretch or shrink. It has the same starting point for the frame as the parent function, 0, 0, so there's been no horizontal or vertical shifts. We'll only have a vertical stretch by 4. Okay, can I ask this question? Did anybody see a graph different than positive cosine? Lydia, what did you see?
I thought it was sine at first.
You thought it was sine? Were you looking at it like...
I think I was just looking at like the whole thing.
Oh, okay. So you weren't looking at a certain part of it. Okay, did anybody else see a sine or anything else? Not an inverse, but a negative. Yeah, you can see the whole negative sign. You could do sine. There is a sine graph. If you started right here at 3 pi over 2, and you went mountain high, valley low. I just didn't give you enough to see like where it ends, so maybe I wouldn't choose that one because like how do I know what my period is then? But I'm going to do in blue just really quickly. There is a negative sine graph that we see the whole thing, right? If we started right here at pi halves 0, if we go valley low and mountain high, that's one period of a negative sign. Okay, so I'm going to talk about y equals a times sine of bx minus c plus d. And that's a negative sign, so I know a is going to be negative. The amplitude is still 4, right? Like it wouldn't matter if it was a sine and cosine and positive or negative, but your amplitude is 4. But because it's a negative sign, the a value changes. Instead of being 4, it should be negative 4 when we put it into our equation. So if that was the part of the graph I was looking at, I would have to say that a is a negative 4. Okay. If I were doing the period part and I had one of these where it doesn't start at 0 for the x, you can always find your period. Little line there. The period is take your endpoint, 5 pi over 2, minus your start point x, pi over 2. That's 4 pi over 2 or 2 pi. And this makes sense that it would have the same period as the other one because it's symmetric all the way through. And so if you have a different starting point, then you can still find that period, which still leads us to believe that b is 1, right? 2 pi over b is equal to 2 pi, therefore b is 1. So a changed, but b stays the same so that I have the same period. Okay. And then let's talk about c over d, or c over b comma d. If this is my frame for negative sign, what's my starting point? That 1 pi half 0, right? It's like the starting point just got shifted right pi halves. So sine actually shares a point with the starting point of the frame. The starting point of the frame should be halfway between the min and the max on the left. So we would be saying the starting point is at pi halves comma 0. That's my c over b and my d. So now I know d is still equal to 0. There was still no vertical shift. But c over b, we said b was 1, right? Is equal to pi halves. This one's kind of nice because c over 1 is just c. So you know c is pi halves. If it was like c over 3, then I would cross multiply and solve for c. But we know c is pi halves. So this equation would look like y equals negative 4 sine of x, because my b is 1, minus pi halves, because c was positive, so it looks like a minus, and then I have plus 0. So if I didn't tell you what frame, which graph you had to do, 4 cosine x is the same graph as negative 4 sine x minus pi halves. But you might have to do a little bit of work to find your A, B, C, or D. I'm going to give you one more to try. Okay, so I'll give it to you. If you want to jot down into your notes, that'd be great. And then I'll give you some time to try to figure it on your own. So this is more like what you'll see in the worksheet that you get for homework tonight. You have to write the graph for a specific frame so that way Fiona's answer is the same as my answer, is the same as Amy's answer. Okay. So it says, write an equation for the graph in the marked frame, and as a helper, what is the starting point of the frame? So anybody want to tell us the starting point for the frame, Randall? Pi over 4, 0? Pi over 4, 1, right? Remember the starting point for the frame, because I got the blue frame right here. The starting point for the frame is on the left side, right in the middle. Okay, so our starting point for the frame is pi over 4, 1. If you want to plot these other points, this is pi 4, 2. You want to label them in your notes. This is pi halves 1. This is 3 pi 4, 0. That's pi 1. This is 5 pi 4, 2. That'll give you a couple minutes, and if you want to chat with your group, I think that's a great idea. Communicating is going to help you like find some of your misconceptions and maybe help some other people out. So see if you can find, what graph is this? What's A, B, C, D? As I walk around the room, I see most people writing down a cosine. So we recognize that within the frame that was provided for us, this graph right here is a cosine graph. Whereas I probably would have, if I had the choice, started it on the y-axis. But I don't have that choice. That one on the y-axis could have been a positive sign. And then I see most people saying it's an amplitude of 1. So remember, pay attention to whether you have the picture of the positive or the negative, because your A can actually be negative when you put it into the equation. Since it's a positive cosine, A is equal to 1. Did anybody figure out what the period of this graph was? Give me the period. See, Grace, did your graph figure a period for the graph? Anybody in your group? Rachel, Ryan, Jillian, you got a period for us? Pi. Okay, we should be able to figure out the period. It's just subtraction, right? It's a distance. So the period is how long the frame is horizontally, like how long it takes to repeat. So when you're trying to find the period, if you're having difficulty, take the end of the frame horizontally, 5 pi over 4, subtract the beginning of the frame horizontally. When it's 0, you probably don't need to do this. You just see what the period is. But you would subtract the pi fourths, and then you're at 4 pi fourths or pi. Okay, so now we know the period is pi, and that's supposed to be 2 pi over b equals pi. That tells us b must be 2. I mean, you can, on this one, I think you can figure out I had to divide by 2 to get 1 pi. If you don't know, remember, you can create this to be a proportion and then cross multiply. So you could say 2 pi equals pi b, and then you would divide both sides by pi, and b is 2. So there will be times when your period, it's not as easy to see what b is. then resort back to cross multiplication. Okay, so I got A is 1, B is 2. And then we already identified together our starting point was pi fourths comma 1. So starting point we said was pi fourths comma 1. Okay. And this is where we're going to be able, because obviously they're not 0, 0, so C and D we have to do a little bit of digging to figure out what those are. Well, every starting point comes in the form C over B comma D. So D is usually pretty easy, right? D is 1. Pi over 4 is C over B. In the last example, B was 1. So whatever the x-coordinate was, that was C. But in this case, we said B was 2. So we're really saying C over 2 is equal to pi over 4. And so C can't be pi over 4. If you divide pi over 4 by 2, you'd get pi over 8 in there. So you have to like solve or figure out, think about, if you're having trouble, this is a great one where, you know, like, again, just cross multiply. You'll get 4C equals 2 pi. You can divide by 4 to solve for C. So C is equal to pi halves. Okay, so if you had C was pi fourths, which I saw in some people's papers as I walked around the room, you're jumping the gun. C isn't like H. We have that B factored in. So it's only equal to the thing in the equation when B is 1. You have to be really careful anytime you solve for B and it's something else. So our equation could be y equals the cosine of 2x minus pi half. Since C was positive, it'll look like a minus. And then plus 1. And that's the only equation that I accept for that picture because I specified the frame. Right? You can't give me a negative cosine for what I showed you in the frame. But if I didn't have the blue box, then Amy could write a positive sine graph. Lydia could give us a negative cosine graph. And Luke could do like a negative sine graph. Okay, so everybody could have, there could be lots of different equations, really infinitely many, because we could just keep shifting over. Okay, but when I specify the frame, there is one correct answer. Anybody got any questions for me? Okay, I'm going to give you your homework, which is a worksheet. If you were confused about homework last night because of the snow days, you know, what I would recommend to you is always write down what our notes are each day, and then on the gold sheet, just pay attention, because we've had 2 snow days, to the section. Okay, that'll tell you which problems to do. Don't pay attention to the dates if you're not changing them with my calendar on the sideboard. So pay attention to the section. But tonight's a worksheet, so you'll be okay. Okay, now if you glance over the worksheet, notice that on the front side, these are going to go by pretty quickly because the starting point for all the frames are where? 0, 0, so you know C and D are zeros. Right? You really got to find A and B's and then what the correct graph is. On the back side, you might want to make a little note to yourself. Beware. There's some horizontal or vertical shifting, so don't jump the gun with that whole C thing. Just because it looks like it's going left pi over 4 doesn't mean that C is negative pi over 4 if B is not equal to 1. So be really careful on that. Okay. Finally, tomorrow is a